I'm going to edit it. Here you go. Here's the picture. We just messed with parabolas. If your parabola faces up or down, this is all you need to know. It's not as bad as it looks.
It looks terrible.
I want you to look at something on this page. This right here, that P is what defines our parabola. It is all about the P. The P is it. It's all in the P. You should probably know what P stands for. I'll define that first so that it doesn't look completely foreign to you. So I'm going to go down yonder. Check it out. It's on this sheet. There's a whole bunch of information. But P right here, it's the focal length. And then the focal length is really just the distance from the vertex. You got to know what that is on your parabola. It's the same as it's always been. To the focal point. That's it. Easy enough. It's all about that. So when I had that graph and I wiggled it all around and we threw that ball over at Nathan, remember when we did that? That was really fun. So we're over here, we shot this thing to the side, and so let's go for like Hervé now. All right, we're going to aim, take this thing off to the side. You grab your parabola. Wherever I put that focus, that's what shapes this thing. It tells me like how close it is. So P is the distance from vertex to focal point. It's this 2.15 number that you're looking at right there. That's the P we're talking about. Shrink it, the parabola changes. Makes it more narrow. Widen it, the parabola widens out. And then you can fling it. See? Now it's like a beeline. Does that look like it's going toward Hervé? Now it's got like a laser sight on it. I don't know. I gotta have fun with this. I've been doing it all day. Cut me some slack. Okay, so here it goes. It's all about the P. And here's where P goes. Jeepers. I've been saying this all day long, and I still have like a 3-year-old's, 4-year-old's humor about this.
Cut the P.
I asked, where does the P go? And it sounds like something I could talk with my 3-year-old about. Jeepers. Because we have that conversation a lot. Okay, there's P. How far it is from the vertex to the focus. And then the directrix is the same distance, it's just the other way. That picture says it all if you can just soak it up for just a second. What if it opens left to right? And I'm just picking up one direction. I mean, they could face either direction. So it's all about the P. Okay, again, it's about the P. In these two equations, if you notice, I bet you could figure out why it's shaped like this. Like the one on the left, if I solve for y, I'd get y equals 1 over 4p x squared. Kind of, that's why it's facing up and down, normal parabola equation. The one on the right, if I solve for y, I'm going to get plus or minus, whoopsie, I'm going to do y equals plus or minus like the square root of 4px. And you can kind of tell that's that sideways parabola. It looks kind of like square root graph, top and bottom. So that's where that comes from, in case you were wondering. If I put the P in that one, the P goes here. And this would be the point P0, P over 0 up. And then the directrix would be at like x equals negative P. That's x equals. The other one was y equals because it was horizontal. This one's vertical. That's normal stuff. It's all about the P. The P is what shapes it. There's even more to that, even than I mentioned we'll get to. Okay, so I am going to go down and draw several of these, and you're going to be just an expert in it. That's just 2 examples. I'm going to unravel it now. You just watch. Okay, you ready to draw quick? There's the up. Faces up. We're going to generalize. It's time to talk about what do we know about P when it's facing up. Well, that's the point 0p. Got it. And then there's y equals p. Obviously, there's going to be more to it than that. We just did this. Y equals negative p. Cool. The vertex is the thing in the middle. That's the corner of it. It's 0, 0 for these examples. One other cool characteristic, I'm going to put it in green. Ooh, fluorescent green. Cool green. Is this width piece right here. How wide it is across here. Now, we call this the focal width because it's not just the width anywhere in a parabola. Because if you can measure anywhere in a parabola, and it's different widths. The further out you go, the wider it is. Oh no, we're talking about the focal width, which is through the focal point. Up top, it defines it for you. It says focal width is, little did you know, 4p. So it's all about the p. P tells you everything. Okay, so you go in there and you say, all right, that's 4p. I like to write it a special way. I know it's 4p, but I like to think of it as 2p and 2p. Or not 2p. To p or not to p? It's really the question. I vote for peeing, because I guess there's consequence for not peeing, I've heard. There it is. 4p, 2p, 2p. It's just a width of 4p. Okay.
How do you know it's 2p?
Why would it not be 2p?
Why can't it just be p?
Because I'll show you. So Mason, man, we would have been done forever ago, but now Mason asks a really good question. So let's spend like 20 minutes answering his question. Okay? So in honor of all of you, we are just going to totally beat this into the ground like I'm really good at doing. So here comes a parallel line. Let me show you. Mason, good question.
Okay.
This, you just tell me how wide it is. I am only going to do it by the mathematics. I'm going to delete a few things, add a few measurements. Okay, measure this.
Measure it.
Good. See, the computer listens to me.
5.32.
Measure this.
It's 5.32.
Thank you. I've already measured the other ones. I'm going to delete one of them because it's distracting. Show label. No. Okay. Y'all see what you got my number? Can you read those numbers? They're really tiny. Can you see that 2.66 is my P? You okay with that being P? Can you see that GA over there is 5.32 and AH is 5.32? About how much bigger is AH than my P? Twice as big. So here's P, and then here's 2P, and there's 2P. That's, I mean, it just is. So think 2,000, think 4,000 years ago, when they were doing conic sections for the first time. This is a 4,000-year-old deal. It's a long time ago. What they did is sat there with rulers and said, man, every time I draw this parabola, isn't that cool, that distance from here to here, and then the distance across to that focal point? Man, it's like there's a relationship. Hey, it's twice as long here, twice as long here. It's 4 times as long across. And they started making, notations of that kind of stuff. Very cool. Remember to stand up and write at your desk if you like. I'll give you a marker if you want one. Okay, so we go down. We got to face this dude down. Same thing. We're going to go green or go home. So let's go with green. There's another one. Oh, it's terrible. Do another one. Yes. There's my parabola, there's my focal point, there's my directrix. The only thing we need to note now is that in this situation where it's facing down, this is the point 0, negative P, and then it's y equals P is my lovely little directrix. The width across, as you know and love, happens to be 2P on either side, or 4P total, so there's 2P. Whatever this is, it's 2P. Yeah, nothing fancy. We do note that, hey, when it's facing down, negative P in an up-down situation is down. That's a big deal. Positive P actually indicates up. Okay, P up, negative P down. To the right. So face to the right. If I graph this one, focus, directrix, point is P0, and x equals negative P. Nothing fancy there. Width, oofda. I do it in green. The width in this case, 2P up, and 2P down, 4P total. That's the story. And then left, I think you got this. Oh, you do. Going to the left. There's P, there's the directrix, got it. Y equals P, no, x equals P, it's a vertical one. And then this point, negative P0. Voila, and then the width across, 2P on either side. Same stuff over and over and over again. Things that I also want to point out is that the vertex is always exactly halfway between your focal point. So here's my vertex. it's always between the focal point and the directrix, smack dab in the middle. So directrix, focal point, vertex. Directrix, focal point, vertex. Vertex is always in the middle. Look at those guys. They're always nice lined up. They're P apart. There's space of P between them. Onward. Down below, I want to come up with the focus, directrix, and the focal width of this. These are all P questions. So all this stuff depends on what P is. So you got to find this magical P. It tells you everything about this parabola. The focal length is really important. So here's what I'm going to do. This parabola opens up and down. There's no doubt about it. And in fact, we know this one opens down. We're super savvy. We know what this equation is. It's a parabola that faces down. So what I'm going to do is go up top, and there's two equations to choose from. There's the up-down equation, and there's the right-left equation. We are going to choose the up-down equation. X squared equals 4py. So with the x squared equals 4py, what I got to do is mess with the one on the left until it looks like the one on the right. Got to mess with it, and then we can find P. It'll be in there. So what I am thinking is I might turn it around. 4py equals x squared, so I did a little turn around. Got to get y by itself, so I'm going to divide by 4p. 1 over 4p x squared. Ooh. So if I'm going to compare that to y equals negative 1/3 x squared, do you see where I'm going here? Do you see that 1 over 4p is going to be my... That's fun. Or, if you're really feeling fancy pants, you could just get this over on the right-hand side, multiply both sides by -3, and it works the same way. You get it in this form. What you have, though, is the P is illuminated if you get it into the right form. Okay, so you match up their forms. If you write them in the same format, you can solve for P. So in this particular process, however you want to write them in a similar side-by-side fashion so they look identical in every way, then you can line up the parts that match. We can go up here and say, oh, 1 over 4p equals negative 1 over -3 if you want to line them up that way. You can cross multiply and divide, or you can just say, hey, 4p equals -3, and p equals -3/4. So the format we have to find p, you have to line them up with one another. They have to match up. So I'm going to show you the other route that I was just mentioning to you is that I could also have multiplied both sides by -3. So you get -3y equals x squared. And if I line that up with the standard form 4py equals x squared, you get the same scenario where, oh, -3 equals 4p, and then you're solving that equation and all is well. My email just went off. Okay, so -3 equals 4p, and voila, we get the same thing. P is -3/4. Awesome. It's all about P. Everything is dependent on P. So now that you have it, you say hip hip hooray. You go to your equation and say, oh, that means my focus is right here. It's -3/4 or 0 -3/4. That's where it's at on the graph. Oh, my directrix. I've got you. It's y equals 3/4. Isn't that great? Oh, you width. I got you. You're 2p that way and 2p this way. So the width on this one altogether is 4p. What is that, negative? That's 3? So this is 3 units long? It's 3 wide, because that's what 4p is. 4p is my focal width, so it's -3. That's my, well, +3 because you're absolute value. So it's absolute value -3. So 3 is my focal width. All these things give you the perfect parabola. Just knowing P tells you exactly what the parabola looks like. Crazy insightful. Okay? That is the story. And now over here, I can be official. It says, please tell me what the focus is.